Chapter 3, Lesson 7. Almost got another chapter down. This lesson's on systems of equations. So, systems of equations. What that means is there is a system made up by two specific lines, right here, both written in slope-intercept form, that happen to have the same answer. So, the same values make both of them true. So, let's look at the first example right here. It says solve the system y equals negative 2x minus 3 and y equals 2x plus 5. So what did they do there? They graphed both of them using the slope-intercept form. Remember that is y equals mx plus b, where m is the slope, and also that is rise over run, right? That is slope. Go up and then over, up, over, up, over. And b is the y-intercept. So that is the place that the line crosses the y. This is always the place you start whenever you're graphing a line. So if it looks like y equals negative 2x minus 3, that means you're going to start down here on negative 3. And you are going to go down because the slope is a negative. We are going to make this a fraction since slope is a fraction. So since this is negative, it's going to go down 1, 2 over 1, down 1, 2 over 1. You can also reverse it if it goes up off your graph and go up 1, 2, left 1, up 1, 2, left 1, up 1, 2, left 1. That gets us that nice line right there. And then if I have y equals 2x plus 5, I'm going to start at 5. And it's a positive 2 over 1, which means I would go up 1, 2 over 1. But if you notice, I'm already off the graph here. So I could also start here and reverse it and go down 1, 2, left 1, down 1, 2, left 1, down 1, 2, left 1. Now, if you notice that line right there and that line right there, they meet at a point. That point right here, negative 2, 1. Negative 2, 1. Now, what does that mean? That means that that is the value, the only value, that makes both of those equations true. So you can check that by substituting in negative 2 for x and 1 for y. So does 1 equal negative 2 times negative 2, which is positive 4, minus 3? Yes. Substitute it in the other one. Does 1 equal 2 times negative 2, which is negative 4, plus 5, which is 1? Does 1 equal 1? Of course. So that is our answer. That is our answer. So now you try A and B. You try A and B. And I'm going to pause it and come back. I'll be on another grid, and I'll show you what these two look like. All right, so pause it and try A and B. All right, hopefully you're back with me now. I'm here with A. And I've got the equations graphed up here for you. Now let me backtrack a little bit and show you how these occurred, just in case they look a little different than yours. Okay, so if one of my lines, my blue line, is y equals x minus 1, I'm always starting at my y-intercept, which is negative 1. Negative 1. And my slope, remember when you don't see a number in front of a letter, you assume it's a 1. And because we need slope, which is rise over run, and we need a fraction, it's 1 over 1. So I'm starting at negative 1. Up 1 over 1, up 1 over 1, up 1 over 1, and that's how I get this blue line right there, okay? Up, over, up, over, up, over. Now, I could also go, if I want some on the left, just reverse it and go down. Instead of up, I would go down. Instead of right, I would go left. And that just gets me my other points on the line. It's not necessary to go the other way, but just in case you want to. Now, the orange line, always start at my y-intercept. Y equals negative 2. That's orange. This time my slope is 2, which is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So that is it. This time I'd go down 2 over 1, down 2 over 1, down 2 over 1. So I can already see the point where they're going to cross. Right here. That point 1, 0, and that is the solution to A. So now let's look at B. B, the first one here is a little tricky only because it does not have a y-intercept, but think about it. What number could you add to 4, 4x, anything really, and never change it? That would be a 0. So that might be something that you might want to add to your notes. If you don't see a y-intercept, you always assume it's a 0. Just like whenever we did the direct variation equations, Remember, they didn't have anything back here, and what do we know about direct variation? They always go through the origin. That's because they don't have a y-intercept listed. You assume it's a 0. So start at 0, and this time the slope is 4. So go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. This is my blue line. Okay, and if I wanted to go this way, I can. All right, so my orange, x plus 3. Again, if you don't see a slope, you assume it's 1 over 1. So I'm going to start at positive 3 and go up 1 over 1, up, over, up, over, up, over, up, over. This is how I got my orange line. All right, and again, I can already see that they're going to cross right at that point right there, which is 1, 4. So that is the solution to that equation. All right, back to the book on this. I want to look at examples 2 and 3 quickly, not necessarily the graphing part, but just the getting the equations part. Number 2, Gregory's Motorcycles has motorcycles, 2 wheels, and ATVs, which obviously have 4 wheels, in stock. The store has a total of 45 vehicles that together have 130 wheels. This is a typical ISAC kind of question. And you can solve it using algebra and not just a guess and check, which sometimes will take you forever. So you can come up with one equation on the number of vehicles, it's supposed to be a C, and one on the number of wheels. So let's look at the vehicles. It says that there's a total of 45 vehicles. So I'm going to say, you don't have to use X and Y. You can use M plus, let's see, ATV, so M plus A. M plus A, we know that there are 45 vehicles. So motorcycles plus ATVs equal 45. That you can get from the equation. You also know that it has 130 wheels. Well, a motorcycle has how many wheels? 2. So I could say that 2M, this just gives me the number of wheels per motorcycle, plus the number of wheels per ATV, and those are 4-wheelers or gators or something, whatever like that, but it does have 4 wheels anyway. That's supposed to be an A. Wow, come on. All right, 4A. So 2 wheels per motorcycle, 4 wheels per ATV, and I have got to erase that. That is pitiful. Pitiful. Let's try that again. There we go. So 2 wheels per motorcycle, 4 wheels per ATV gives you a total of 130 wheels. Now, I could graph that. I could graph that. I would have to have them in slope-intercept form, which the same kind of thing right here. Now, this one on number 2 just says write the system. That's the system. You don't have to solve by graphing. It just wants you to write that. But notice that these, neither one of these are here like y equals mx plus b. So they could give you ones that look kind of funny, and you're going to have to rearrange. So if we know that slope-intercept is y equals mx plus b, and I have something that looks like this, then I know that if I have to get y by itself, then that means I need to subtract x from both sides. So I would have y equals negative x plus 45. That is my equation. Next one, 2y plus 4x equals 130. If I have to get y by itself, I need to move this 4x to the other side. So 2y plus 4x equals 130. So I would subtract 4x from both sides. Now, notice what I'm doing here. This is a plain 130, and this one has an x on it. Those are not like terms. I cannot subtract those. I just simply have to write them next to each other. So I've got 2y equals negative 4x plus 130. I'm just going to write them over there together. Y has to be by itself, so divide by 2, divide by 2, divide by 2. Y equals negative 2x plus 65. Y equals 2x plus, negative 2x plus 65. So here are my equations that I would then have to graph. Okay? So, moving on from that. Now, those all have an answer, and they all have one nice and neat answer, which is exactly where they cross. But as you know, we can't just leave things nice and neat. There are some things that happen to make them not so nice and neat.